Hi everyone, in this video we're going to be going through a set of video solutions for the 2021 Math Standard Task 3. It was on a bunch of different topics, so we'll start going through it. Alright, question 1, we have a non-right angle triangles trigonometry question involving bearings and involve sine rule, cosine rule, and all that kind of stuff. So to start us off, we have the diagram, and the bearing of C from A is 250 degrees, and the distance of C from A is 36 kilometers. So, first of all, we're told that the bearing of C from A is 250. So what we can say is that angle here, starting from north and going in that clockwise direction, is 250 degrees. So in part A, we need to show that theta equals 110. Well, at A, there's 360 degrees in a whole revolution. Simply, all we need to write is theta equals 360 degrees minus 250 degrees, and that equals 110 degrees. Fairly simple. Like it's giving you the answer in the question. It's only 1 mark. You just need to pretty much have some kind of calculations to say that why it's 110 degrees. And yeah, so you do need to at some point mention that 110 is 360 minus 250. So if you just did like 70 plus 40, bringing numbers out of nowhere and said that was 110, that's not good enough. You need to, like with this show question or explain question, it needs to come from the question. For part B, if B is 15 kilometers north due of A, so that's what we're saying here is that's 15. Show that the distance from C to B is 43 kilometers, correct in years kilometer. So again, this question is saying show that the blah is 43 kilometers. It's telling you what the answer is. Again, you just need to find what that is. You just need to show that that comes to it. So what we have here is a non-right angle triangle. So we can, if it helps, just draw the diagram again of what we do have. So we have this. We know that's 15. We now know that's 110 degrees. And even if you couldn't do part A, you can still use part B because that's why it said it as show. That's 36, and we're trying to find what x is. All right, we're trying to find the distance from C to B. So from that, this is a cosine rule question because we have 3 sides and 1 angle. So we're just going to say x squared, and that equals 15 squared plus 36 squared minus 2 times 15 times 36 times cos 110. Alright, when you put that onto your calculator, you'll get 1,890.381 . And of course, that's on the end of the question because that's what x squared is. So to find what x is, we just do the square root. So x equals 43.47 ... So therefore the distance is 43 kilometers to nearest kilometer. Alright, so like I said, the question is, in the question is telling you it's 43 kilometers, so you do need to get to 43 kilometers. It's just showing. And again, the reason why it's presented as a show question is because we then need to use it in the next question. So hence or otherwise, so because it's saying hence or otherwise, that's basically saying use your previous answer to find the next bit, okay? So whenever you see hence or otherwise, it's really saying use what you just found. Find the bearing of C from B correct to the nearest minute, alright? So making sure we're looking at correct to the nearest minute. That was an error with some people who were just doing it to the nearest degree. Making sure we're reading the question carefully. So we're trying to find the bearing of C from B. That means we're trying to find, because it's saying from B, we're trying to find this bearing, right? To be clear, we're not trying to find that bearing, right? Because that would be B from C, but we're trying to find C from B. So we have all this information. We're told that that's 15. We're told that this is 110. And we're told that this is now 43. We can just use that as 43. You don't need to use the full 43.47 blah blah blah, because in the previous question it said rounded to 40, like the nearest kilometer, so you can use that rounded number if it told you to do that in a previous question. And so what we need to do is, if we're trying to find this bearing here, that means if we can find this angle that's sitting in here, let's call that alpha, alright? That means if we find that angle, we can do 180 degrees plus that angle that we found in there, and then that would be the bearing. So to do that, we'll use sine rule. So we can say that, I'm going to call that alpha, so we have sine alpha over, so if we're saying that that's alpha, that means 36 is opposite it, so it's going to be over 36, equals sine 110, so I'm just looking at the other angle I have, so that's 110, and the side opposite is 43, and like I said, you can just use that rounded answer, because in part B it told you to the nearest kilometre, so you can use it to the nearest kilometre now. So once you do your sine rule, you know you multiply the 36 over, and you do inverse sine of that, we'll get that alpha, or it's a bit stuffed up here, but we have 51 degrees and 53 minutes, right? That's what alpha comes to, but of course that's not the end of the question, that's not the bearing. The bearing needs to be that, so we're saying in here is 51, 53, so we're just going to add 180 to it, so therefore the bearing equals 180 plus 51, 53, so 231, 53. Sorry for the board stuffing a bit there, it's a bit dodgy. Alright, going into the next question. So this one is on simultaneous linear equations. So for a baker making pastries, the initial cost is $A, so the initial fixed cost is A, and the production cost is $B per pastry. So basically saying that A is going to be our y-intercept, that's the initial cost, and B is going to be the gradient, the rate of change. So the maximum daily production is 120 pastries a day. The graph below represents the daily production of n pastries. Okay, so this is that graph. So we want to find the values of A and B. Well, remember we're told that A is that initial cost. Okay, so A is just going to be the y-intercept, and the y-intercept here is 100. Okay, so whenever we see initial, word initial, whether it's linear or non-linear, initial means when x equals 0. We're talking about the y-intercept. So that's one mark for just saying A equals 100. B is a little bit more tricky because we need to find the gradient. So if I were to choose 2 points, maybe if I choose this point and this point, so starting on that left point, I've gone up 180, so my rise is 180, and then across I've gone 120. So that means B, being the gradient, alright, or the rate of change, is going to be 180 over 120, and that equals 1.5. Right? What that means in context of the question, going back up to here, right, it's $B, so that means it costs $1.50 per pastry made. So to make the pastries, there's an initial cost of $100, and then for every pastry that's made, it costs an extra $1.50. Alright, so we've done that. So 1 mark for finding A, 1 mark for finding B. Question B says, pastries are sold at $4 each. On the axes above, draw a line representing income. So this is basically just saying draw a linear relationship for this. We're told that pastries are sold for $4 each. So that means the rate of change, that gradient, is going to be 4. So we can say that the income equals 4 times n. And there's not going to be any y-intercept, or the y-intercept is going to be 0, because if you've sold no pastries, you've made no income. So that's it. We're just simply got, so we're going to be starting at the origin, and then we just need to do some tables. We can do a table of values, or just plot some points. So if I make n equal 20, alright, that'll be 4 times 20, so that'll be 80. If I make n equal 40, it'll be 160. If I make n equal 60, this will be 240, which is about there. So just plotting a few points. If I make n equals 120, I'll get 480, so it might be worthwhile to see what happens at the end as well. But you'll see, you know, assuming that you have a ruler, unlike what I do here, you should get a nice straight line, go from there. And lastly, is the baker able to achieve a percentage profit of 100% by selling pastries within 1 day? justify your response with making appropriate calculations. So this question is a bit different to your normal break-even point questions. Like, the question isn't asking, will this person make profit? Because yes, if they will make some profit, our break-even point is at 40. So once they've sold 40 pastries, they'll start making profit. What the question is asking is, will we make 100% profit? What that means is, will we kind of like double our money is what it's saying. So first we need to see selling pastries within 1 day. Well, we can first see how much is it going to cost to make 120 pastries, because that's how much you can make in a whole day. So the cost of making 120 pastries is going to be, just looking at this line here, $280. Alright, and then the income for making pastries, 120 pastries, you can just put it into the equation that we had here. Alright, so 4 times 120 is 480, or you can just look at it on the line as well there, and that's 480. So therefore the profit after making 120 things, the maximum amount they can in a day, is going to be $200. So we found what the profit is, but we want to find the percentage profit, and you might remember this from earlier years. The way that we find the percentage profit is we get that profit of 200, we divide it by the cost price of 280, and when you get that, where's my calculator? So if I do, remember we'll times it by 100 as well to make a percentage, and we're going to do 200 divided by 280, and then times it by 100, and then this will give us approximately 71.42%. Alright, so from that we can say, therefore, basically we're not making 100% profit. So no, the baker cannot make 100% profit in 1 day. So the board's just stuffing up again, but you can imagine what I'm saying. So to make 100% profit, you need to basically say, because it costs $200, they'll need to get $280 cost. That means they'll need to get $280 profit to make that 100%. But because the profit was less than that, they didn't make enough. So that's for that question. Going into the next one, this is on bivariate data analysis. So look at this. So each member of a group of males had his height and foot length measured and recorded. The results were graphed on the line and best fit by eye was drawn. So George is 10 centimeters taller than his brother Harry. Use the given line of best fit to estimate the difference in their foot lengths. So a common mistake that was done here is people just kind of chose any 2 points that were 10 centimeters apart. So maybe they chose this person, and they just assumed that that was George and Harry. And they're like, oh, well, the difference in foot length between these is 2, right? So they just said, well, the difference is 2. But you don't know that these two people, that's George and that's Harry, or vice versa, or whatever. We don't know who the people are. But it even says, use the given line of best fit. Like, it's not even telling you which points to look at. It's just saying, look at the line. So what we're saying here is, if we just choose any 2 points on the line, maybe this point and this point, we see that they are 10 centimeters apart, right? And then the difference in foot length between these two. So this person is 22, this person is 25. So the difference would be 3 centimeters difference. Okay? And the idea is, it doesn't matter which 2 points you choose. Like if I choose here and here, they're still 10 centimeters apart, and there's still 3 centimeters difference. If I choose here and here, again, 10 centimeters apart, 3 centimeters difference. So the idea is to make estimations without knowing exactly which dots represent George and Harry. They might not even be one of the dots. We just got to use the line of best fit. That's the whole point of line of best fit, is to interpolate or extrapolate to make estimates. Going to question B, why does the value of the y-intercept have no meaning in this situation? So there's a couple of kind of right answers for this, but there are lots of wrong answers as well. First of all, some people just said there is no y-intercept, and you might be able to say that, like, just looking at this, there is no y-intercept drawn in this line, and that's kind of correct, but we need more detail as to why it really doesn't make sense. So by definition, the y-intercept is when x equals 0. Okay, that is when the line cuts the y-axis, which is when x equals 0. And in this case, the x-axis represents height. So what we're saying here is we need to find the value of the y value when x equals 0. But if you're saying that x equals 0, that means you have a person who's 0 centimeters tall, like they don't exist. So basically, you can say like a y-intercept means height equals 0 centimeters, which isn't possible. I mean, and that's just what it comes down to it. Like, it's like y-intercept means x equals 0, and you can't have a height of somebody being 0 centimeters. That means they don't exist physically. So that's what it really came down to. Like, just conceptually, why doesn't it make sense? A student calculated the correlation coefficient of this set to be negative 1.2. Give 2 reasons why the student is incorrect. Well, first of all, just looking at the line of best fit and the general pattern of the dots, we say that they're going upwards, right? That means it has to be a positive correlation, which means the correlation coefficient needs to be positive, although this student has found it to be negative. So that's one reason why they're incorrect. It should be positive. Alright, so that's one reason. The other reason, what a couple of people did is they actually found the correlation coefficient using the dots that were on there, and I think they found it to be like 0.85, and they said, well, because it's 0.85, not negative 1.2, they are incorrect, and I did give them marks that because that is a reason why they're incorrect. But more conceptually, we know that correlation coefficient needs to be between negative 1 and 1. But this person's found it to be negative 1.2, which is impossible. You can't have a correlation coefficient like less than negative 1. So basically, if we just say R needs to be between negative 1 and 1. Alright, just conceptually, it needs to be between negative 1 and 1. This student found to be negative 1.2. It's not possible for it to even be correct. Alright? And lastly, write the equation of the least squares line of best fit for this data. I'm not going to go through the whole process in this video. It's kind of like a separate thing, but what you need to do is put all these dots into your calculator. Like, put all this data set into your calculator using the bivariate functions, and then using the quick methods on your calculator, find the value of a and b, and then just put it into an equation. So once you put all the dots in and you find the value of a and b, you'll eventually round it to 2 decimal places. You get y equals 0.24x minus 19.73. The other thing you can do is go through those big ugly formulas where you find the gradient by doing the correlation coefficient times the standard deviation of y over the standard deviation of x, and that finds the gradient 0.24. And then if you do that other big formula for the y-intercept, that can also work, but just remember, this is 1 mark, so the idea is you're just putting numbers into your calculator, find the value of a, find the value of b. Going to the next question, this is an annuities question. So, the table below shows the future value of a $1 annuity at different interest rates over different time periods. What would be the future value of a $6,500 per year annuity at 3% per annum for 7 years with interest compounded annually? So, we've got per annum, we've got annually, 7 years, basically nothing needs to change. Alright, we don't need to make any modifications, we're just looking at the 3% column, we're looking at 7 years, so we have that. And we're trying to find the future value, so that means we're going to do 6,500 and just times it by that future value interest factor, 6625, and then that will give us $49,806.25. And what that is saying is this person is putting $6,500 per year for 7 years, and they're getting a little bit of interest on top of it. So how much is that investment going to be worth after those 7 years is what the future value means. Question B, what is the value of an annuity that provides a future value of $100,000 after 9 years at 5% per annum compound interest? So again, no changes need to be made. We're just looking at 5%, 9 years. So we're looking at that 11.0266, except we're doing an opposite now. So we know what the future value is. We need to find the value of the annuity. So in part A, we knew what the value of the annuity was, and we just times it by the interest factor to find the future value. We're doing the opposite. So because we're doing the opposite of multiplication is division. So we're going to do our $100,000. We're going to divide it by 11.0266, and that gives me $9,068.98. And what that means is for us, like in 9 years' time, if we want to get $100,000 in this investment, each year I'm going to need to put in $9,068.98. So at the end of those 9 years, with interest compounding at 5% per annum, we'll eventually have $100,000 pretty much exactly. So we're doing the opposite. And then lastly, for question C, this is kind of like a combination of both of them. So an annuity of $1,200 per 6 months is invested at 6% per annum, compounded biannually for 5 years. So this time we've got like $1,200 per 6 months, 6% per annum, and biannually for 5 years. So that means we are going to have to do a couple of changes to the numbers. First of all, we have 6% per annum, so that's going to be, because we're doing biannually in 6 months, so that's going to be 3% per 6 months, and then biannually for 10 years, so that's going to be 10 time periods, okay? So rather than looking at 6% for 5 years, we're going to be looking at 3% for 10 years, which is going to give me 11.4639. And then, so we just got that $1,200. So we got that $1,200 times it by 11.4639. And then that gives me $13,756.68. Now, what I noticed some people doing when I was marking this is they found that number correctly, 11.4639, except they times it by 2,400, like 2 lots of 1,200. You don't need to do that because by making these changes of 3% and 10 time periods rather than 6% 5 time periods, you've already made those adjustments. So we're putting in, you know, me looking at a different number on that table kind of adjusted for all that, so I don't need to do 1,200 times 2. Alright, it's already been accounted for. So we have that, and now that's how much, that's the future value, so that's 1 mark for it. But the question isn't asking us to find the future value, it's asking us to find the amount of interest that was earned. So what we need to do is we need to see like how much we improved by. A common mistake they did, and some people did, is they just got that value and then subtracted it, so 13756.68, and they subtracted it just by 1,200, okay? The problem is, we haven't just put in 1 lot of 1,200, we put in 10 lots of 1,200. Remember, we're doing it every 6 months for 5 years. So really what we should be doing is we should be subtracting that by 10 lots of 1,200, okay? Which is 12,000, and when you get this, you'll get $1,756.68. Alright? So we haven't just put in 1 lot of 1,200, we've put in 10 lots of 1,200, which is $12,000. And so we've got our future value of $13,756.68. Subtracting $12,000 will get the answer. Going into the next question, this is on nonlinear relationships. And the first one was a bit tricky, but what it comes down to is algebra, which is still in the course, so you should still be able to do it. So we're told we have 80 meters of fencing is to be used to create a rectangular enclosure using two existing walls as shown in the diagram below. So we're told that the length of one of the sides is X. We're also told we have 80 meters of fencing. So if this side here is X, that means this other side can be represented as 80 minus X. Because what we're saying here is we have 80 meters of fencing, so whatever was used, so 80 minus X, so whatever was used here, whatever is left over will be used on the other side. So for instance, if that was 30 meters, then this we know would be 50 meters. If this was 10 meters, this would be 70 meters, right? Because we're told we've got 80 meters of fencing. So if that's X, well, that's just going to be 80 minus X, okay? So we have the length and the width being X and 80 minus X. We need to show that the area of the enclosure with X can be expressed by the equation blah, blah, blah. Well, how do you find the area of a rectangle? Just length times height. So we've got X times 80 minus X. It might just be easier if I just write without the multiplication sign. And then we're just expanding. Alright, so to expand the brackets, we do X times 80, which is 80X. And then X times negative X minus X squared, which is exactly what we're trying to find. Alright, so only by marking that, it's realizing, finding that that's 80 minus X, and then multiplying that with X and expanding. So we have that. Secondly, on the axis below, draw a sketch of the graph represented by this equation. So we're told what the equation is. So we have 80x minus x squared. So we've already been told what the equation is. We just need to sketch it. Straight away, you should be thinking, well, what type of graph is this going to be? We have an x squared in there, so that means we should be thinking as a parabola. And because in front of it is negative, that means it's going to be a concave down parabola. But enough about that. What we can just do is plot some values into this. We can do a table of values or whatever, plot some points and go from there. So if x equals 0, first of all, well, 80 times 0 is 0, minus 0 squared is 0. So here we have a point there. When x equals 20, what we'll do, 20 times 80 is 1,600, minus 20 squared is 400. So 1,600 minus 400 is 1,200. So here we need to show the corresponding a values on the vertical axis. So that's where we actually need to put in the values on the left here ourselves. So in these kind of boxes that were given to us, I'm going to make that 400, I'm going to make that 800, I'm going to make that 1,200, I'm going to make this 1,600. Now it doesn't actually matter what you do, as long as you're consistent. What I saw a lot of people doing, and this is a big mistake, is, people found that for 20 it's going to be 1,200, and then for 40 they found 1,600. Okay? Problem is we're saying that that's 400 here, okay? From there to there is 400, but that same distance below is 1,200. You have an inconsistent scale, which is totally wrong, okay? You can't do that. We need to make sure that they're equally spaced. So that's why I start with 400 here, and then 800, and then 1,200, and then 1,600, because now they're evenly spaced with 400, okay? You need to do that. So when x equals 20, y equals 1,200. When x equals 40, so 80 times 40 is 3,200. Minus 40 squared is 1,600, so 3,200 minus 1,600 is 1,600. When x equals 60, we have this. When x equals 80, we have this. And there's no point of actually having to go beyond 80 because it's not physically necessary anymore. We can't have a negative area, alright? We can't have negative lengths as well. So from this, we now just have a few things. And we know that this is a parabola, so it should have a relatively nice parabola shape. It's not the best parabola I've ever drawn in my life, but it's good enough. The problem that I saw with some people's graphs is that they were doing that kind of thing. It has to be a parabola, it has to have that curved shape. Alright, so if you weren't having that curved shape, well then that's not good enough. You need to realize that this type of nonlinear relationship, a parabola, has that curved U shape. Alright, so you get 1 mark for getting the graph correct, you get another mark for having the y values on the left. Alright, and then lastly, using the graph, state the maximum possible area for the rectangular enclosure and the dimensions required for the enclosure. Well, we've got to look at the vertex, like the top point of our graph. So the max area is simply just looking at this point is 1,600 meters squared. And as for the dimensions, well, when y at that point, at that point when y is 1,600, we see that x is 40, right? So we got that 40 meters. And if the length is 40 meters, so if we're told that that was 40 up here at the top, well then if we do 80 minus 40, well then that's also 40. Okay? So the dimensions is 40 meters by 40 meters. So when we're asking for dimensions, it's really just asking what's the length and the width. Okay? And then the last question, this is on normal distribution. So metal rods are manufactured with a mean length of 6.25 centimeters and a standard deviation of 3 millimeters. Before we go any further, note that they're not the same unit. Alright, that is a trick. We have 6.25 centimeters and a standard deviation of 3 millimeters. So this equals 0.3 centimeters. And you need to be using 0.3, or you need to convert the 6.25 centimeters into 62.5 millimeters. You need to make sure that the units are the same. So what z-score corresponds with the rod length of blah blah blah. So we'll just find the z-score. This is just basic z-score formula. So we've got 5.65 minus 6.25 the mean over 0.3 the standard deviation. Again, it needs to be 0.3. It can't be 3 because that would be the incorrect unit. And when you put that into your calculator or whatever, you get -2. Alright, so z-score -2, 1 mark, you just got to get that. Next, this is kind of like the opposite version of this. So here we're saying a rod has a length that is 1.25 standard deviations above the mean. What that's basically saying is it has a z-score of 1.25. Okay, remember the z-score, or the standardized score, tells you how many standard deviations away from the mean we are. So we can just put this into the z-score formula. So we've got 1.25 equals, and we're trying to find what that score is. So in the previous question, we knew what the score is. We need to find the z-score. Now we have the z-score, and we're trying to find what the score is. So minus 6.25 over 0.3. And then to solve this equation, we'll just multiply the 0.3 over and then add 6.25. So we get x equals 6. Oops, I might just use space. X equals 6.625. Okay, we're trying to find what score gives a z-score of 1.25. And the way that you can check to see if you answered right is put that into the z-score formula. 6.625 minus 6.25 divided by 0.3. It would equal 1.25, so that's correct. Lastly, another longer question. A batch of 1,500 rods is delivered to a factory where they are to be used as parts in the machine. Rods that have lengths less than 5.65 or greater than 7.15 do not meet the factory's requirements. Assuming the lengths are normally distributed, that's really important to have there. If it didn't say that sentence, that means we wouldn't be able to use the 68, 95, 99.7 rule. Alright, so we need to know that they are normally distributed before we can use that. And approximately how many of them will be unsuitable. Alright, making sure that we're reading the question carefully. A couple of people found how many rods were usable, but we're trying to see how many aren't going to be usable or unsuitable. Alright, so what we need to first do is find the z-scores for each of these. Well, for the z-score for 5.65, we actually found that in question A, that was -2. And we find the z-score for 7.15, that's going to give me a z-score of 3. Okay? So what we're saying here is any rod that has a z-score lower than -2 or a z-score that is greater than 3 is unusable. It's either too big or too small for the factory. So what we need to do now is find what percentage lies between those things. So there's plenty of different ways of doing this, but the way that I'm going to do it is the percentage between -2 to 0, first of all. Percentage, we know using the rule that the amount of scores between -2 and 2 is 95%, using the 68, 95, 99.7 rule. So we got 95%, but I'm only doing -2 to 0. So that's going to be half of that, so it's going to be 47.5%. So that's half of 95%. And then the percentage between 0 to 3, well, that's that 99.7% is between 3 and -3. So we can halve that again to get 49.85%. So that means the percentage inside the range, so percentage inside range is 97.35%. But that's the amount that's going to be useful for the factory, so it means outside the range is going to be 2.65%, right? I want to focus on the 2.65% that aren't suitable for the thing. And then so therefore we're going to get 2.65 times it by 1,500, because that's how many rods there were, and that gives me 39.75. So therefore approximately 40 are unsuitable. And we'll round it to the nearest whole because it doesn't make sense for, 0.75 of a rod to be useful. We'll just round it to the nearest whole. Okay, so, if we get 39.75, it means around 40 are going to be unsuitable. Anyway, those are the solutions for this assessment task. So hopefully this video will be useful for you to go back, check your work, and if you have any more questions about these, be sure to ask. All right, thanks for watching the video.